Welcome back to the next part of solving by elimination. So we just did the really easy stuff where it's all lined up for us and it's really nice and easy. I think I said that already. So what do we do if there's not already opposites? That's the big question. So let's look at this new worksheet that you picked up. And we'll come back to number one, but I want to start with number two. Just because of the way that it works, because that's what I want to do, because I'm the teacher. Nobody's here and I'm talking to a screen, so I can do whatever I want. So let's look at number two on that. That's the one that says 8x plus 9y equals 82, and 2x plus 2y equals 20. So everything is nice and lined up, so that step one that was on our last note sheet said line everything up in standard form. That's already taken care of for us, so that's good. But we don't have opposites this time, so the problem becomes, wait, if we add these up, nothing's going to eliminate. That's the whole purpose of elimination, is to get things to eliminate. So what we do is we make it so. We make it opposites. We can multiply any of these equations by any number that we want. That's like kind of the cool magic trick that we can do, is we can multiply any of these equations by any number to create whatever numbers we need. The only thing that we make sure have to do, let me say that sentence again. The only thing we have to make sure that we do, I still don't think that's a good way to say that. That's awkward. We just have to be careful that when we multiply, we're multiplying an entire equation. We can't just multiply one part of the equation. We have to multiply the whole equation by whatever it is that we're wanting to multiply. So that's the only caveat to this. So when I look at this, I see the 8x and the 2x, and I'm thinking to myself, man, those are not opposites. Boo. But I could make them opposites, right? I could take this 2x and make it the opposite of the 8x. How might I do that, you may ask? Well, come closer and I'll show you. Ha ha ha. Weird. It's like you just moved, but you didn't. So the way that I would think about doing this is, well, the opposite of 8x is negative 8x. So I need to multiply this 2 by something that's going to give me a negative 8. I wonder what that number could be. What could you multiply by 2 to get a negative 8? That's right. Good job, kids. Negative 4. Because 2 times negative 4 gives me a negative 8. That would make opposites. Does that make sense? Are you with me? Good. So what I'm going to do here is I'm going to multiply this entire second equation by negative 4. Again, why negative 4? Because that's the number that's going to make it work. That's the number that's going to make these opposites. When I do that, negative 4 times 2, that's a little arrow. That's really bad. There we go. Negative 4 times 2 is negative 8. Boom. Negative 4 times 2, y is negative 8y. And negative 4 times 20 is negative 80. Notice how I had to multiply everything by that negative 4. I multiplied it all the way across. Distributive property, essentially. And then the top one is good. We're going to leave it alone. So I'm just going to rewrite it. 8x plus 9y equals 82. Hopefully you're doing this with me. So what we've done here is we multiplied the bottom by negative 4. That's what made the opposite. So now that I have opposites, now I can finish the elimination problem. Now I'm going to add up all of my parts. The 8 and the negative 8 will cancel. They go away. 9 minus 8 is just 1. And 82 minus 80 is just 2. So I've already, boom, got my y value. Now remember, once you have your y value, you want to go back and plug it in to find your x value. How can you do that? By plugging it into whatever you want to plug it into. Doesn't matter, don't care. I'm going to take this and I'm going to put it into that second equation because it has 2's and they look smaller than the 8 and the 9. So I'm going to go with that. So we're going to go y equals 2. So we're going to change that to a 2 plus 2 times 2. So I just plugged in the 2 where the y was in that second equation. And now I can solve it for x. 2x plus 4 equals 20. Subtract 4 on both sides. Divide by 2 on both sides. And x is going to equal 8. So again, the whole piece to this is that beginning part is the important part where we want to multiply to get opposites. Once you do that, then you're set up for success and you can solve it the same way we have before. So yeah, that's it. Any questions? You can't ask me because I'm not really there. But you could ask me in real life when you see me or walking around. You can raise your hand and ask me questions. Or you don't. I don't care. Let's look at one more. Uno más, un más. I don't know. Number 6. Let's do number 6. That seems cool. So if I'm looking at number 6 does something kind of interesting. Can you see it? Yeah, you can see that. Okay. Number 6, 10x plus ay equals 66 over 5x plus 3y equals 31. So again, I don't have opposites. Everything's lined up, so that's good, but I need to make opposites. How do I make opposites, you ask? Easy. Multiply. So what I'm looking at is the 10 and the 5. That to me looks like something that they're not opposites, but I could create them fairly easily. I need to double this 5. I need to multiply it by 2. That's going to give me 10. But be careful, because just getting the exact same number is not going to help. Because then when I go to add them, well, 10 and 10 is going to give me 20. So I don't need the same number. I need opposite numbers. Since they're both positive, I'm not going to just multiply this thing by 2. I'm going to multiply it by negative 2. That negative is going to change the sign so that it becomes the opposite. And the 2 is going to get it to be the same number. If you remember, the last notes we took said that our goal is to get the same number but the opposite sign. So sometimes we need to multiply by a negative to make sure those signs become opposites. Does that make sense? Hopefully. So when I multiply all of that by negative 2, 5 times negative 2 is negative 10. 3 times negative 2 is negative 6. I'm running out of space, but yeah. 31 times negative 2 is negative 62. And then the top one is going to say the same. I'm just going to rewrite it. 10x plus 8y equals 66. Just trying to keep everything nice and lined up. Now when I add up my parts, things will cancel. So the 10 minus the 10, they cancel. Or 10 plus negative 10, I guess I should say. When I go to my y values, 8y and then negative 6y, that makes a 2y. And then 66 and a negative 62, well, that makes a 4. Divide by 2 on both sides. And we just solve for y. What? It's 2. That's a 2. And then to find x, you just plug it back in. Like this. That one. That one seems easier. So we're going to make that y a 2. 5x plus 3 times 2 equals 31. So 5x plus 6 equals 31. 5x equals... I just multiplied the 3 and the 2 to get the 6. Now it's a two-step equation. Subtract 6 from both sides, and you get 25. Divide by 5 on both sides, and x equals 5. That's cool. Fun. Awesome. Math. Bye. I'm done.